Okay, so then let's start. Hopefully everything works because obviously I have a bad connection here. Sorry for that. Yeah, I wanted to give you some updates on heat pumps, which have been mentioned already several times today, not only from Klaus Peyerhuber, but as well from Hans von Steen. And I want to give you some ideas. First of all, why are we talking about heat pumps? Then only for those who are interested, how does it look like? What is the technology behind it? Then an example, what we are doing currently. So to get an idea about the whole thing. So let's first start, why are we talking about heat pumps as such? If you're looking to the final energy consumption overall in Europe, you see, or you will notice that approximately only 1/3 of the energy consumption is coming from electricity. And the further 20% are exactly the discussion we had with Hans van Steen about transportation, what's ongoing there. But approximately half of
Alexander, sorry for
yeah,
interrupting you. I will share the presentation. You should see it now. I think
fine
it's
with
just a
me.
little bit faster. Just say
It's
forward,
okay.
yeah? If you okay.
Yeah,
Sorry.
it's okay, no problem. Fine
Thanks.
with me. Thanks for supporting. Yeah, and so as I mentioned already, so the half of the final electricity consumption is heat. Very simple as that. And the question is what to do with heat in the future, and how to decarbonize heat. Because if you're looking a little bit closer to heat production and cooling as well, so you will see here on the right side that approximately half or more of half of this heat production is still produced from fossil fuels, however they are looking like, up to 2/3 of that heat. And to decarbonize that one is most probably not that easy. And how could it done? And here maybe heat pumps could be one option for further support. If you could go to the next slide, please. Just take a look on how we are heating currently and how many district heating networks we do have in Europe. And that's really a lot. And these district heating networks normally are taking their heat more or less out of fossil fuels, either produced in combined heating power plants or something else. And this decarbonization is not that easy, not to take into consideration what's happening with individual heating sources. But let's only focus on the district heating networks. And this will be definitely a challenge to decarbonize that one. Also, some cooling networks are already existing, but these can be neglected for the time being. The other topic where we have to think about how to decarbonize heating and heat is thinking of industries, because there are several industries existing which need some heat for their production, process industries, for instance. And there as well, the requirements are very different. Some industries are only requiring something up to 60, 80 degrees of Celsius, which maybe is not a real topic. But there are also some, for instance, take food and beverage. They need temperatures between 120 and 150 degrees Celsius. Also, these ones to decarbonize won't be easy one. So, but maybe we can go to the next slide and immediately then, most probably, if I remember well, switch one more slide further. Yeah, thank you very much. So as I mentioned, I want to give you some ideas about heat pumps. And the basic principle of heat pumps, I think, is quite well known to everybody of you. A heat pump is in principle an inverted refrigerator. So you are taking some heat from a heat source and utilizing that heat for a medium which then will be compressed by means of electricity by that compression, a lot more of heat is generated, which can be then taken out and fed wherever you need it, and then the medium is flowing back. And the tricky topic here is, if you're taking the heat from where it's available or easily available, you need only a little bit of electricity for the compressing to take out a lot more of heat, or heat at higher temperatures than you had before. So really to make it more usable. And so this exactly is the principle of heat pumps, as mentioned, like inverted refrigerators. And if we can go one slide further, please, to give you an idea as well how that looks like. So these are some larger heat pumps, not the small ones you find at your homes maybe. These are some larger heat pumps with around 16 megawatt, only to give you an idea, consisting of a motor for the compressor, then some coolers, condensers. So it's not really rocket science, but nevertheless there are some topics behind which are not so easy to solve. Maybe on the next slide, if you please go further on. Thank you. So what we can provide here as part of our portfolio of Siemens Energy are heat pumps in a smaller size from 5 megawatts, 8 megawatts up, and then really up to large heat sizes up to 70 megawatt thermal or even more. And which is mainly maybe most interesting, especially for process industries, up to 150 degrees Celsius, which, as I mentioned earlier, is required for certain industries, and which is definitely not easy to generate, but we can provide that. You see here on the right side as well the wording environmental friendly, because this is currently an issue which is heavily discussed in the whole EU. Think of the ban of fluent gases, SF6 or things like that, for switch gears and other things. So we are working with some work mediums which have a very low GVP or ODP, so that is really possible also in front of the upcoming tight regulations of the European community to be used further in the future as well. So maybe then example how it looks like in reality, if you could go further on, please. Yeah. I wanted to give you the idea of the project in Mannheim, where there is installed a large heat pump to provide the district heating of the city of Mannheim. So how does it work? The heat source in that case is the River Rhine. Sounds a little bit funny, but this is enough to provide enough heat then to be converted for the requirements of the district heating network. So the River of Rhine normally has approximately 25 degrees in summer and not less than 5 degrees in Celsius in winter. And this is already sufficient then for the complete district heating generation. So the River of Rhine is taken out, which the challenge there had been also to design the whole installation in the way that this is environmentally friendly, that no harm is done to some fishes or whatsoever. So that really everything fits to the environmental requirements of the River of Rhine. And there is the outtake is maximum 700 liters per second from the river. And then, as shown before, this is utilized via a compressor and heating up the medium up to a temperature approximately 100 degrees, which then is fed into the into the district heating network. So overall, so we are using there 7 megawatts of electric power necessary to power the compressor. This electric power is used from renewables, preferably, of course. And with the whole circle, we can produce, and we are producing 20 megawatt thermal energy, which is used for the district heating. So this is able to provide and to supply around 30,000 households in the city of Mannheim with the necessary district heating. So the overall savings here in emissions, because in former times this district heating was realized via an old coal-fired and gas-fired power plant, which is no longer used now. So the overall savings are more than 10,000 tons of CO2. If you compare it, for instance, with a normal gas-fired boiler, which had been in use as well. To give you an idea how the whole installation looks like, maybe you can go to the next slide here. So there is an overview of the installation. So this is 18 meters long and 5 meters high. So not a very small one, to be honest, but at least please consider this is really something to be utilized on large scale. If you go one more further, so here's some more details and the views. You see here a link on the upper right side, which I have provided, and you can utilize then afterwards when reading the presentation. There is quite a nice time-lapse video available where you can see how the whole installation was built up from the scratch. And to follow up what's happening here. We have a similar project currently under realization in Berlin. So there, the source of heat is not a river. So there is a large office area at Potsdamer Platz, with a lot of coolers, cooling towers, and some things and similar things. And this heat, which is utilized, which is coming from the cooling towers, is up to recently was not used. So we are using there the heat also for as an input for a larger heat pump. There only with a thermal capacity of 8 megawatts, so this is a smaller one. And then producing district heating between 85 and 120 degrees Celsius. The interesting thing in that installation is that this is really very dynamically operated, depending on how much heat is produced by the office spaces, how much heat is needed by the district heating, which is not constant over the year, which is changing, as mentioned, between 85 and 120 degrees. All that is to close these examples. All that is nothing new. So this is only a more consistent application of existing technology. And because we have already realized such a project with a similar solution in Stockholm already in 1980. And since then, this is in operation. There we used as a heat source the seawater from the sea. So my major message is everywhere where you have large scale heat sources available, be it sea, be it river water, being cooling devices whatsoever. So it's obvious to utilize that one as heat source to power it up with such heat pumps and to provide district heating, for instance, and in a similar way, which I did not mention today, in a similar way as well, some industries with large heat demands as well. So I think that's all from my side, and I hope I gave you a good overview about what's possible. It's more or less the same what you're doing when installing a heat pump at your home, but only in a much larger size and therefore also maybe very often much more viable from a business point of view. Thank you.